Hello everyone, welcome back to our class. Let's continuously learn Chapter 10, Radiation. Section 3, Radiation and Geometrical Factor. For any two black surfaces, because only part of the energy emitted from one surface can reach another surface, the other energy is dissipated into the space. For example, here is two surfaces. From surface 1, give some energy to half space. Only part of the energy can reach surface 2. So, as the same way, emits the energy from surface 2, only part of energy can reach surface 1. In these two surfaces, how to heat exchanger. Before this, we give some definition, the geometrical factor. The definition is the ratio of the energy incident on the second body to the energy emitted by the first is called geometrical factor. We remember expressed x1 to 2. Energy from surface 1 to reach surface 2 means the ratio is x1 to 2. The view factor x1 to 2 equals q from 1 to 2 over q1. Over q1 is x1 2. Certainly, in the same way, we can have x2 to 1 equals q2 to 1 over q2. We obtain these two factors. Hence, per unit time, the radiation energy emitted by the first surface and to reach the second surface is EB1 times A1. A1 is the area of surface 1 times x1 to 2. Means from surface 1 emit the energy reach surface 2, the part. Similarly, the energy from surface 2 to reach surface 1 is EB2 times A2 times x2 to 1. Only part of energy can reach surface 1. These two terms minus just the net radiation between the surfaces. So Q1 to 2 equals EB1 times A1 x12 minus EB2 A2 x21 is the net exchanger. This equation certainly at any condition is right. If the energy is balanced, the temperature is the same, certainly Q12 is 0. Just to say, when T1 equals T2, Q12 is 0. From this equation, we easy to obtain A1 times x12 equals A2 x21. You can find it is symmetrical relationship. No relationship with the energy. Only is geometrical relationship. From this equation, it can be found geometrical factor has not relation to the process. No relationship with the process. Only relationship with the geometrical factor. With the relationship of A1 times x12 equals A2 times x21, we can calculate the radiation of black surface. So Q12 equals EB1 minus EB2 times A1 x12. Also equals A2 x21 EB1 minus EB2. Also equals EB1 minus EB2 over 1 over A1 x12. So 1 over A1 x12, we can think this term is a resistance, radiation resistance. So we use R to express it. So equals EB1 minus EB2 over R. This RR is resistance called radiation resistance. The section 4 will give some discussion about properties of geometrical factor. We know geometrical factor is very important parameter in radiation heat transfer. Geometrical factor is a very important coefficient to calculate, to evaluate the radiation heat transfer. It has several very special properties. One, the symmetrical relationship means A1 times x12 equals A2 x21. So there is some symmetrical. From one geometrical factor to calculate another one. 1, 2, 3, 4. There is 4 parameters. If we know 3 parameters, we can calculate the next one. The second, the completeness of geometrical factor. For a closed surface, if the system is closed surface, which has several elements, any element surface, to see the whole surface has geometrical factor is 1 because the surface is closed. So the total factor certainly is 1. So xi1 plus xi2 plus xin together xji from 1 to n together certainly is 1, just 100%. The third, the resolvability of geometrical factor. For example, here is one surface, here is two surfaces. However, two surfaces can separate two parts, A and B. In this case, resolvability of geometrical factor x1 to 2 and 3 equals 1 to 2 plus 1 to 3, 1 to 3. So also A2 and 3 times x2 and 3 to 1 equals A2 x21 and A3 x31 together. Geometrical factor of two infinite plates. If the plate is very big, also close each other. In this case, very small radiation lost. So in this case, x1 to 2 equals x2 to 1 equals 1. Very close to each other. 5. A non-cave surface is completely enclosed by other surface. The radiation from 1 to 2 is received completely by 2. So x1 to 2 equals 1. At the same time, you can find if A1 is non-cave, non-concave, enclosed by another surface. So from 1 to 2, x1 to 2 is 100%, just 1. So from 2 to 1 is A1 over A2, 1 over A2. At the same way, if a non-concave body, for example, a ball, is completely enclosed by other surface, closed. So from 1 to 2 is 1. x2 to 1 is A1 over A2. If A1 is very small, A2 is very big. So x2 to 1 is 0. Okay, this page will give several very special systems the geometrical factor, how to calculate. For example, two dish together, x1 to 2. In one cylinder surface, there is a ball like this, x1 to 2. Here is a dish, here is a larger dish, x1 to 2. Here is another picture, is a ball and a very bigger dish together. We can use this equation to calculate. Sometimes we can use some diagram to check geometrical factor. For example, here is a square surface, square surface, two square surfaces. The distance is d, width is x, length is y. In this picture, x over d from 0.1 to 20. The vertical axis is x1 to 2. You can calculate for different y over d, different y over d, the curve, we can calculate x over d. To check this picture, we can obtain x1 to 2. Also, for example, two circle dish, parallel circle dish. The distance is x, the diameter is d, vertical axis is x1 to 2. Horizontal axis is d over x. We can check the axis x1 to 2 to obtain the geometrical factor. Here is another picture, one vertical area and horizontal area. In this case, also we can obtain x1 to 2, 1 to 2. Thank you very much.